So continuing with 7.8, this is 7.8b, and we're ready for example number 2 right now. Okay, so in this one we have 3 inequalities that we're going to be looking at here. So let's look at each one. Let's graph each one separate. So x plus, in fact, what I'm going to do here is I'm going to color code everything. So we'll do the first one in green. Make it equal to 4 and find out what x and y's will give me 4. So 1 plus 3, 2 plus 2, 0 plus 4. So 1, 3, 2, 2, and 0, 4. Okay, so that gives me a dotted line. Okay, and we'll do the next one in red. So x equals 0. Remember, you have to set it equal to. So graph x equals 0. So x equals 0 means that I don't go left or right any. I just go up or down. And because it is a greater than or equal to sign, I'm going to have a solid line right there. And then y is greater than 0, so I'm going to write it, or greater than or equal to 0, y equals 0, and we'll do this in blue. And y equals 0 is a solid line because it's greater than or equal to. Now I have to look at each one in shade above or below that line. Alright, so let's take this top one and take a point. Let's take point 0, 0 and see if that's part of the answer by plugging it in here. Is 0 plus 0 less than 4? Yes, it is. So that means I can shade everything below that green. Because if 0, 0 works and makes it a true statement, then every number on that side of the line will make it work. Okay, so that is for the first one. Alright, let's look at the second one. X is greater than or equal to 0. That's the pink line right here. So I'm going to look on this side of the equal sign, or this side of the red line, to see if one of these numbers will work. So I'm going to pick, let's see, I'll pick a number over here like 1, 2, 3, 4, 5, 6, 7, 8. Let's pick 8, 0. And let's plug that in. Plug it in here. Is 8 bigger than 0? If I put 8 in here for x, is that a number bigger than 0? Yes, it is. So that means everything over here is going to be shaded. Okay, now let's look at this one. Let's pick a number above the line. So let's pick a number like right here. That's negative 2, 2, 3, 4, 5, 6, 7, 8. 8. Alright, so if y is 8, is y greater than or equal to 0? Is 8 greater than or equal to 0? Yes, it is. So that means everything above the blue line is a solution here. Alright, so what I'm interested in is where all 3 of these intersect each other, and we'll show that in yellow. Right here, here, and here. That area right there all has blue, red, and green in it. So that ends up being where my answer is that I'm looking for. And again, you got to remember that you still have your dotted line here. And we still have our blue line here. And we still have our pinkish line here. So you can't forget to have those parts in it. So dotted, solid, solid. And everything in there is shaded because that's where all three of them have things in common with each other. Okay, let's look at the next one. So this is example 4. We have x minus 2y less than or equal to 4. We have x plus y, which is less than or equal to 4. And we have x, which is greater than or equal to negative 1. Alright, so let's graph each one. So the first one is going to be x minus 2y equals 4. And what we're going to do here is we are going to make it equal to y. So negative 2y equals negative x plus 4. Divide by 2. Divide by 2, and I have negative y equals negative 1/2 x plus 2. And now it's in slope-intercept form. It's in the form y equals mx plus b. Okay, so see what I did here. There's a 1 in front of the x, so that's how that became this. And 4 over 2 is 2. The only problem we have is this negative sign. So remember, to get rid of the negative, you just get rid of it and change the sign of everything else. So that, in order to graph, we go to our y-intercept, which is negative 2, and we have a slope of 1/2, which is y over x, which means we go up or down 1, left or right 2. So up 1 over 2. And because this problem up here is a less than or equal to, we get a solid line. Alright, so let's go ahead and get rid of as much of this as we possibly can here. And let's do this part. So x plus y equals 4. And we just, again, it's easier just to make a little table here. You could set it up, bring this and put it over here and get y equals negative x plus 4. You could do that. Or you could set it up as a graph here. Either way, you're trying to find what x is, trying to find what y is, so it doesn't really matter whether you use a slope-intercept form to find the slope, or the y-intercept and then the slope, or if you use the little table here. Let's just use the little table. It's two numbers added together to give you 4. So negative 2 and 6. So 0, 4, and negative 2, 1, 2, 3, 4, 5, 6. And again, it's got the less than or equal to sign, so it's going to give me a solid line. Alright, so let's go ahead and look at the last one. X is greater than or equal to negative 1. Well, when x is greater than or equal to negative 1, let's see, let's use red. No, let's use green. And let's make my pen thicker so you can see it. Alright, so when x equals negative 1, that means we have a vertical line that is solid because of the greater than or equal to sign. So there's my 3 points there, or my 3 lines there. Alright, so what we're going to do with that is find out where the commonality is between all 3 of these. Alright, so I am going to see how much of this I can erase. Doesn't look like I can erase much of anything there. So, alright, so I erased everything, and these are our 3 original. And here's the graph right there of all 3 of these. So, the green is the bottom one. The red one is this one, and the top one is the blue one. Alright, so that's the graph. So let's go ahead and plug a number in for this above the blue line to see if the above the blue line or below the blue line gets shaded. So I always like to pick 0, 0 because it's the easiest one to work with. So let's put 0 in. And determine if 0 minus 0 is 0 less than or equal to 4. Is that a true statement? Yes, it is. So therefore, everything above the blue line gets shaded. Okay, so let's look at the next one. And the next one has to do with the red line. So we're going to take that one and we're going to pick the number 0, 0 again and see if everything below this line or above this line gets. In fact, now let's pick 1, 2, 3, 4, 5. Let's pick 5, 5. Let's pick a number up here above it and see if it gets shaded up there. So 5, 5. 5 plus 5 is less than or equal to 4. Is 10 less than or equal to 4? No, that is not working. So because 5, 5 doesn't work, none of the numbers up here work. The only ones that are going to work are the ones below. Okay, next we're going to look at the bottom one right here. We'll do that in blue, and that is, in fact, that's the green line right here. So maybe we should do it in green instead of blue. There we got blue. Alright, so x is greater than or equal to -1. We're going to pick a number on either the right hand side or the left hand side. So I like 0, 0 whenever I can use it, so I'm going to use that. Is 0 greater than or equal to -1? Notice we don't have a y, so even though this is the point 0, 0, we don't care about the y value, we just care about the x value. Is 0 greater than or equal to -1? Yes. So since 0, 0 works, then everything on the same side as 0, 0 is going to work here. And again, it gets kind of messy, but what I'm interested in is where all three of these intersect, which is right there. So let's do that in yellow. So that ends up being my answer, where all three of those shaded parts intersect there. And that is 8.8. So in the homework, you're going to do the same thing I did for 1 through 18. And for 19 and 21, they're asking you to come up with an equation that's going to make that work. And so I'm going to skip that. So let's just do 1 to 17 odd. And then we'll do 25 to 33, all of those. And those are just review of previous lessons. So that's it for lesson 7.8.